Good morning, dear students. Hope you are doing well. As I said before, in the yesterday class. Today we will start where we left yesterday. Okay. In the yesterday class, we discussed what is the need of compiler, why it is important, and what are the different variants of compilers available, and what different roles they played. Why compiler is important for CSE and allied branch students. How compiler is acting as a backbone in the programming language. And we also seen what are the different phases available in compiler. Today we'll take a deep, in-depth analysis to analyze how different phases of compiler works. How each and every individual phase of compiler works. We'll analyze them with the help of an example. For each phase, we'll take the example. Okay. So as we know that a compiler has multiple phases. Like the first phase of compiler is lexical analysis. Second phase of compiler is syntax analysis. Third phase of compiler is semantic analysis. Fourth phase of compiler is intermediate code generation. Fifth phase of compiler is code optimization. And the sixth phase of compiler is code generation. Additionally, two other techniques, two other phases are there. One is symbol table, which is nothing but a data structure, which is to store the information, and it pass the information to each and every phase as per their requirement. And another phase is that is called as error handler, which throw the error whenever any phase find a error. That error passes to the user through the help of error handler. Error handler is named not only to pass the error to the user or to the programmer, it also helps the user or the programmer in order to recover from the error. So this error handler has two different works. It plays two different roles. One is it helps the user or the programmer in order to identify the error. Then it also helps to recovery from the error. Okay. So this much we covered yesterday class. In today's class, we are going to cover the rest of the things. I am Dr. Sudarshan Behra. I am working as an assistant professor in SR University in the Department of CSE and in the School of Computer Science and Artificial Intelligence. Okay, let us start today's class. Yeah, as you see in the screen, the first phase of compiler is lexical analysis. What it does, what a lexical analyzer does, that we are going to discuss now. The functions of lexical analyzer, it reads the source code character by character. It does not read the source code at a time, okay, or word by word, or line by line. It does not do that. Rather, it reads the source code character by character. And upon finding a sequence of characters together, that is called as a lexeme or word. Upon finding a word, it try to identify what type of word it is. It try to identify the class of that word. That process is called as tokenization. So the major function of lexical analyzer is tokenization. So it reads the source code character by character and it converts that character into tokens. What is token? Token is nothing but the class of that word. Suppose three consecutive words are there. After reading one by one word, whenever three consecutive words are together, it finds three consecutive words together, then it identify what type of word it is. Is it a character? Is it a character? Is it a string? Is it a constant? If it is a constant, is it a real constant? Or it is a floating point constant? Or it is a keyword? Or it is an identifier? Or it is an operator? So it try to identify the class of that particular word. So the process of identifying the class of that particular word is called as tokenization. And for each word, there is a class that is called as a token. Okay, so you concentrate on the second line, what it is saying. The second line saying that it converts the characters into tokens. Okay, then while reading the program or while converting the words or lexeme into tokens, it eliminates some things. That means it remove white spaces and comments from the program. These are not going to execute. Okay, these are not the executable codes. That is why it removes them. The rest of the codes it convert or it identify the tokens for them. Okay, so lexical analysis is the first phase of the compiler, and it breaks the program into meaningful units called token. This is the primary role of lexical analysis. Now the question is, if it identify a word or lexeme and it also identify the corresponding tokens of them, then where it stores them? Because lexical analysis does not have any storage unit. Okay, so it stores them in a data structure called as a symbol table. Is that clear now? So lexical analyzer, it identify the word and then it find out the corresponding class or the token of that word. Then it stores all the information in the symbol table. Okay, all the information in the symbol table. Now you understood the purpose of symbol table? Very good. Now let us take one example. Here you see, concentrate on the right part of the slide. There is one expression given, position equals to initial plus rate into 60. Okay, position equals to initial plus rate into 60. This is one mathematical expression. Let us assume that this expression is written in the code, whether C or C++ or Java, okay, any language. This piece of information or this piece of expression is there in your program. Now, if the lexical analyzer reads this piece of information, then what it does? Okay, upon reading that, whenever it start reading from P, because P is the position is the first, first word. So it will read P, O, S, I, T, I, O, N, character by character. Whenever it reaches to the last character N, starting from P and the last character is N. So now the entire word is called as position. Then it identify what type of word it is. Is it a constant? No. Is it a keyword? No. Is it an identifier? Yes. Position is an identifier. So as position is an identifier, the class of the position is identifier. So that is why in short you see what is the output of lexical analyzer? ID1. That means in that line the first identifier is position. So that is why in short it is written as identifier, in short written as ID1. Identifier 1 means ID 1. Next, it reads equal symbol. Equal symbol is predefined already. It is known to the compiler. You cannot, or we are not going to, we never define the equal symbol. Okay, as it is predefined, the symbols or the operators are predefined. This is one operator. So whenever it reads equal symbol, it identify it as an operator. As the class is predefined, I mean everything is known to the compiler, so it does not perform much action on that. It is just identify, yes, it is an operator, then it will proceed. The next word is initial. Again, initial is what? Is it predefined to the compiler? No. It is one user-defined variable. It is an identifier. So this identifier number is what? The identifier number is 2. This is the second identifier which is encountered by the lexical analyzer. So that is why it generates the class. That means token type of the word initial is identifier 2. So in short, it is written as ID2. Next, it reads the plus symbol. Plus is an operator which is predefined. So it does not perform much things. It does not perform much action on that. Okay. Then it reads the third word which is present in the line, that is rate. Rate is what? Rate is again an identifier because it is user defined. So the rate, as it is an identifier, so what is what is the sequence of this identifier? The sequence, the sequence of identifier is 3. So it generate the token type is ID3 into is, then it reads the into operator. Into operator is into is an operator, so it just identify it, and it does not create anything for the in the symbol table because the operator is predefined. Then it reads 60. 60 is a constant which is known to the compiler, so it does not create anything new and placed in the symbol table. So for position, initial and rate, it just creates the identifier number, that is ID1, ID2, and ID3, and it stores them in the symbol table. Okay. So this is the task performed by lexical analyzer. Okay. Now next go to the, so this, once it identify all the token types, it stores the information in the symbol table. The next phase of the compiler is syntax analyzer. What it does, it collect all the token types and all other information for, it collects all the token. Identifier 1 is a token, plus is a token, equal symbol is a token, 60 is a token, into is a token, identifier 2 is a token, identifier 3 is a token. It collects all the tokens from the symbol table, then it performs its task. That is the role of syntax analyzer. Now see in the next slide, what is the role of syntax analyzer? 1 second. Yes, the second phase of syntax analyzer. The second phase of compiler is syntax analyzer, and it is also known as parser. What it does, it collects all the information, all the tokens, which is stored in the symbol table by the previous phase, that is lexical analyzer. So it collects them and it checks whether all the tokens are arranged as per the grammatical rule or not. So basically, it checks the grammar of a sentence. Okay. If you say position equals to initial plus read into 60, then it checks whether this expression is written correctly or not. I mean, the grammar of the expression is correct or not. Okay. So to do that, what it does, it imposes a grammatical structure, a predefined grammar on that sentence in order to check whether the sentence is grammatically correct. Okay. Whenever we are speaking in any natural language, we are normally discussing using Telugu, Tamil, Uriya, English, Hindi. These all are the natural language. Whenever we are communicating with others in natural language, there also we are taking care of grammar, because without grammar, our sentence, whether in written or in orally spoken, okay, it will be wrong. Because of lack of grammar, you cannot able to make a sentence properly. Okay. So in order to make a proper sentence, in order to speak, in order to write, we are taking the help of grammar. Okay. So similarly, here also it has a predefined grammar known as context-free grammar. I hope you already studied in automata theory and automata theory or theory of computation. You have already studied what are the four types of grammars are there. One of them is context-free grammar, which is used in compiler. Now you just recall that. Okay. So here the context-free grammar is used by the second phase of the compiler, that is called as syntax analyzer or parser. Okay, in order to identify whether the sentence is grammatically sound or not. Okay. So what is the output? Okay, it imposes the grammatical structure on the collected tokens and it checks whether the sentence is correct or not. Okay, the tokens are properly arranged or not. Okay, you imagine if you write 60 equals to int a, is the sentence will be correct? No. But what will be the correct sentence? Int a equals to 60, right? So there you can analyze what is the difference between both the sentences. The first one was incorrect and the second one is okay. Int a equals to 60, that is the variable declaration or initialization. Of course, followed by semicolon will be there, but semicolon is removed while by the lexical analyzer when it further process the inputs. So now you see in this diagram, it collected the tokens and it imposed a grammatical structure. Okay, the grammatical structure cannot be discussed in this class because we are not discussing in depth, because we need to discuss the few more things before we go to the grammar. Okay, that will become in the second unit when you will go to syntax analyzer in depth. Okay. So overall, you just identify, you just try to understand. Once it collected the tokens, and let us assume that it imposed the grammatical structure on them, and then how it perform the analysis, whether the sentence is correct or not. How it analyze, how it identifies. It identify that by constructing a kind of tree known as parse tree or grammar tree or syntax tree. So the output of syntax analyzer is nothing but a syntax tree, or also called as parse tree. Through this parse tree, once it imposes the grammar on the collected tokens, then it produces a parse tree. And through that parse tree, it identifies whether all the tokens are arranged in a particular grammatical order or not. If not, the syntax is grammatically ill. Okay? If it identify the all the syntaxes are follows the grammatical order as per the tree is constructed, then it declares that the sentence is grammatically sound. Okay, so that is the role of syntax analysis. So it checks grammatical correctness, it builds parse tree, it detects syntax error. How syntax error? A equals to 5. Suppose A is a variable, you declare A equals to 5. In the second statement, you declare that, or you initialize A equals to 5. This sentence is correct. But you cannot write 5 equals to A. Okay, it does not have any meaning. 5 equals to A, that means a constant cannot have a variable as a value. But if you are writing A equals to 5, that means you are assigning the value 5 to the variable A. That sentence is correct. So that it identifies by the grammatical, predefined grammatical rules. Okay. The parser verifies whether the program follows the grammar rules of the programming language or if the sentence follows the predefined grammar rule, then the sentence is very correct. That means there will be no syntax error. Okay. If not, definitely the error will come to the user. That program is syntactically ill, or this particular line syntax error is associated in this particular line. Okay. So in this way, the syntax analyzer works. And what is the output of a syntax analyzer? The output of a syntax analyzer is nothing but a parse tree, derivation tree, also known as the syntax tree. So remember, the tree has many, nicknames, you can say. Parse tree is also called as syntax tree, is also called as derivation tree, is also known as a grammar. One tree has 4 names, don't confuse. Okay, it represents the same tree. All the names represent the same tree. Okay, good. Next, what is the third phase? So this tree, parse tree, is passes as an input to the third phase of the compiler. Okay, what we have seen first, the lexical analyzer, it produces the tokens and store in the symbol table. And the syntax analyzer collect the tokens from the symbol table and impose on grammatical structure on them. Predefined grammar, which checks the syntactical validity of the sentence. If the syntax is valid, it produces the syntax as an output. This syntax tree is further passes as input to the third phase of the compiler, that is semantic analyzer, or you may say semantic analysis. Okay. Then let us see what semantic analysis does. Go to the third slide. Yes. Here you see semantic analyzer, or the third page, or semantic analysis. What are the functions? It checks the meaning of the sentence. It also performs type checking. It also checks the variable declaration is correct or not. So this is the role of semantic analyzer. Semantic analyzer, it checks the meaning of a sentence. Meaning of a sentence means what? A sentence is written. If the grammar is correct, does it mean that syntax is meaningful? It may be, it may not be. So it checks the eventual meaning of the sentence. Whether the sentence has a particular, it has, is it delivering some meaningful things or not? That is the role of semantic analyzer to check, and simultaneously it also perform other kind of checks. Okay. If you write int a equals to 5, yes, it is understood. That means we can understand that the integer variable a, and its value is 5. Okay, this is correct. Syntactically correct, and the meaning also correct. Anyone can easily say that value 5 has been assigned to the variable a, which is integer type. Okay. This is grammatically correct, and the meaning also correct. But if you write a sentence int a equals to 5.7, this sentence is grammatically correct. Nothing wrong in grammar. I mean, the syntax analyzer cannot catch this error. If any error is there also, lexical analyzer pass it. Because in lexical analyzer, int is a keyword, a is one identifier, equal symbol is operator, which is predefined, and 5.6, 5.7 or 6. It tell 5.7. Because you wrote int a equals to 5.7. 5.7 is real constant. Everything is valid. Lexical analyzer store them in the symbol table. Syntax analyzer collect them from the symbol table. It identify int is an integer. A is means identifier. Okay, and the identifier and the value is assigned 5.7. The sentence is grammatically also correct. Syntax analyzer passed. Now the third phase, semantic analyzer. It has the responsibility to check the meaning of the sentence. Here you observe int a equals to 5.7. What is the type of a? The data type of a is integer. And what value you assign? You assign 5.7 to the variable a. That means floating point value you assign. Is it meaningfully? Is it correct? Is the eventual meaning of the sentence is correct? No, because the type of variable is a, and you assign a real, real number or a floating point number. You assign a floating point number or a real number to the variable, which type is integer. The variable type is the integer, but you are assigning something else to that variable. How that variable can hold that value? So the sentence is meaningless. Okay, the eventual meaning of the sentence is 0 here. So this type of error, it will show you the error. Did you observe anytime type mismatching? One type of error, if you write C program, C++, Java, okay, it will show you, the compiler will show you the one type of error is type mismatching or typecast problem. Your cast is one, you are assigning something. Okay, there is a problem of typecasting. There is a problem of type mismatch. So the sentence is meaningfully does not have any meaning. Okay, so this type of checking is done by semantic analysis. Now, this is a small example I gave. When you will discuss semantic analyzer in depth, multiple examples, in multiple directions can be cited. We will be discussing that. For what we are discussing actually in this lecture, we are discussing, we are knowing the roles of different phases with the help of example. Okay, but we are not discussing the entire topic of of a particular phase. Entire topics available on a particular phase that will be discussed. So now it also check variable declaration, type checking, and the type checking. I mean, just now I given that example based on the type. Okay, type mismatch, variable declaration. Sometimes you may declare initial. Sometimes you may declare a variable multiple times. Int a equals to 5. Within the same scope, int a equals to 10. How it is possible? How one variable can be placed in the same location? It is not possible. Okay. Can you able to create the same word file and can you able to store them in your desktop? Same word file 2 times with the same name. Is that possible? Check it. Today you check it. You remember the file type should be same and the file name should be same and the place, whether in C drive or D drive or in your desktop, okay, or any location or within a folder, can you able to keep the same file with the same name? Can you able to store that 2 times? You check it. It will never. You will never be. If you store second time or third time, automatically system will make the changes, and finally the original file will be there. The second file will be called as the copy. Automatically copy word will be added into the file name. Okay, the same file you cannot store in the same location more than one time. In the same way, how one variable can hold 2 different values and store in the same place of the memory. Okay, this is also one of the major role of semantic analysis. So, like this, many examples can be given, but when we will be discussing the topic in depth, the particular chapter, whenever we will visit. Okay. So, more or less, this it also perform type conversion. You see in this example, the parse tree, which is given as an input to the semantic analyzer, you just identify the parse tree. ID1 equals to plus ID2, the left child, and into is the right child. Then for into, the left child is ID3 and 60 is the right child. This is nothing but a tree. A tree has a root and it has many nodes and many leaves. I mean, interior node and child node. This passes to the semantic analyzer. Then the semantic analyzer, what it does, it is scan the tree again. Once again, it is scan the entire tree to check the meaning of the sentence. You see here, you see the last part, ID1 is as it is, plus is as it is, equal symbol is as it is, the root, ID2 is as it is, ID3 is as it is, but only changes down to 60. Okay, only changes down to 60. Why? Why changes down to 60? And in between one operator is inserted called as into real. Into real. Okay, that means 60 is not declared as a real number. Whereas assume that other identifiers Let us say the data type of position. Okay, the position is float, and the data type of rate is float. The data type of initial is also float, but the the constant which is added or multiplied, okay, that is a whole number. So here there is a type mismatch, okay, because the data type of position is taken as float. How it can hold the real constant? I mean, whole number, whole number. So that is why it is essential to convert that whole number into real number. Okay, how to convert? There are two types of conversion performed by this semantic analyzer. One is implicit conversion, which is happen by the machine. It does not need your help to convert. And another type is explicit conversion, where users specify, yes, convert this integer number to real number, or convert this real number to double. Okay, change the type. I mean, that is called as a typecasting. Change the data type. That we need to exclusively mention in the program so that the machine can, or the semantic analyzer can. But sometimes if we don't specify also, the semantic analyzer can do, but that is all, there are some limitations. Okay, it can convert a lower number to higher number. I mean, 60 is a integer constant. 60 need to be converted to real in the sense 60.0 is the real number. That 0.0, okay, 60 to 60.0, that kind of lower to higher, that conversion is called as implicit conversion, and it is directly done by the system. I mean, by the semantic analyzer. Okay, so that kind of conversion is called as implicit conversion. So that is why, so as we already assumed that position is a floating point variable, so it must hold floating point. Integer, initial also floating point variable, rate is also floating point variable, but the only constant given here 60 is an integer constant, so it cannot be multiplied directly with the real number. It cannot be added directly with the any real number, so it needs to be changed. So now the role of semantic analyzer is to change 60 to 60.0 integer constant to real constant. That is why to do that, it has some operators which is predefined to the system or the compiler. One of the operator is called as into real. That means it convert it converts that constant integer constant to a real constant. It will just make 60 to 60. For that, it needs an operator. So that is why you see the output of the semantic analyzer. In the output, the same tree is there, but only little modification has done. One interior node has been inserted, that is as an operator, that is called as into real. Into real is an internal operator which is assigned in the tree, and the child is again 60. Once this operator is assigned, 60 is automatically becomes 60.0. Okay, the system will treat it as 60.0. Right? So this is then this particular tree is different from the previous tree, and this tree is also called as abstract syntax tree. So what is the output of semantic analyzer? Semantic analyzer, after scanning the entire tree, okay, whenever required, it performs some action, like it add one operator, okay, and it convert the integer constant to floating point constant if required, okay, and then it finally produce the same tree with some decoration, and that tree is known as abstract syntax. Previously, it was a syntax tree, the output of syntax analyzer. Now it is known as, the output of semantic analyzer is known as abstract syntax tree. This abstract syntax tree is again passes to the Next phase, fourth phase of the compiler, that is called as your intermediate code generation. So this abstract tree is the input to the intermediate code generation. Now we'll see, after upon encounter the abstract syntax tree as an input, what the intermediate code generation does, the fourth phase of the compiler. I hope you are clear with the role of lexical analyzer, the role of syntax analyzer, and the role of semantic. Now we are going to see the role of intermediate code generation as you passes the output of semantic analyzer, that is abstract syntax tree, as an input to the fourth phase, that is intermediate code generation. Let us see the role of the fourth phase. This intermediate code generation, what it does, that we'll see in the next class. And let us stop here. Okay, we'll see in the next class what the intermediate code generation does. Okay, so thank you all, and have a good day. Thank you.